Okay, in this lesson, we are going to add and subtract rational expressions, which is a little bit harder than multiplying and dividing because you do need a common denominator. So we're going to start with a warm-up, just reviewing how to add and subtract fractions. And so when you add and subtract fractions, you have to have a common denominator because you are going to keep that denominator. And so 1/3 plus 5/3 is 6/3, which we know is 2. Here we are not ready to subtract because we need a common denominator. We can't add 7/2, or we can't subtract 13/6 from 17/2. But we can turn this 2 into a 6 if we multiply top and bottom by a 3. And so the only legal move for a fraction is to multiply the numerator and denominator by the same factor. So in this case, that factor is 3. And so this problem turns into 21/6 minus 13/6, which will be 8/6. Yeah. And then that simplifies to 4/3. Always simplify your final answer. Next, to get a common denominator, we actually have to change both fractions this time. In number 2, we just had to change the 7/2 because it was easy to turn a 2 into a 6. Here, there's no way to turn a 3 into a 5 or a 5 into a 3. And so the least common denominator between these two would be 15. And so when you're looking for the LCD, the least common denominator, you're looking for the number, the smallest number that is divisible by both denominators. So in this case, that number's 15. You don't want to go too big on these. With numbers, it's okay. With functions, it's not okay. You're going to end up with a really high degree polynomial that you won't be able to simplify. And so my first fraction, I need to multiply top and bottom by a 5. My second fraction, I need to multiply top and bottom by a 3. And so my new expression is 5/15 minus 3/15, which is 2/15. That can't be simplified, so we are done. Okay, so here we're dealing with variables, and so same rule applies. You're only allowed to multiply top and bottom. Some people try to, let me just square top and bottom. That's not a legal move for a fraction. For example, if you have 2/3 and square the top and bottom, you would get 4/9. These are not equivalent fractions. And so each time you're only allowed to multiply. So if I were to multiply top and bottom by a 3, this would be 6/9. These would be equivalent fractions. And so to make these denominators match, you don't want to square the first fraction. You want to multiply top and bottom by x. And so that would give me x/x² plus 5/x². Add the numerators, you just get x plus 5 over the x². And then remember, those x's can't cancel because we have a plus sign. Here, our LCD would be xy, and so we just need a y top and bottom for the second fraction. So 2/xy minus 7y/xy equals 2 minus 7y/xy. And in these cases, we can't simplify the numerators because we can't combine 7y and 2. Those aren't like terms. Here, our LCD would have to be divisible by r and s, and so rs would be our LCD. So I would multiply top and bottom by s, multiply top and bottom by r, and so I would get 6s/SR minus 5r/SR, which is 6s minus 5r/SR. And then remember, you can't cancel anything because of this minus sign. All right, so we're going to continue to add and subtract these rational expressions, but now they're going to get a little more complicated. And so We are going to start off easy. And so this first example, they already have a t in common. So looking at the 10t and the 15t. So as we build our LCD, we need to account for everybody's factors. And so we need at least a t because they both have t. And then between 10 and 15, the smallest number that's divisible by both of those would be 30. Okay, and so to turn both of these into 30t, I would need to multiply the first fraction by 3 and the second fraction by 2. So that would give me a 9 over 30t plus 4 over 30t, which would give me 13 over 30t. And that's as simple as it can get. Over here, remember, you're not allowed to square top and bottom. And so this is technically the same as x plus 3. And so our LCD is going to have 2 copies of x plus 3 in order to be divisible by this denominator. And so my first fraction needs another copy of x plus 3, top and bottom. And so that gives me 2 times the x plus 3. That 2 is going to get distributed. Plus, and then we didn't do anything to the second fraction. And all of this is going to be over x plus 3. Sometimes I skip to just writing the final fraction, just one fraction bar, and then just focus on simplifying the numerator. And so distribute your 2. You get 2x plus 6, and then we still have this plus 3. And then that simplifies to 2x plus 9. And then don't forget the denominator. That's still going to be part of your final answer. Oops. And so if you wanted to rewrite the denominator as x plus 3 squared, you could. I like to leave it like this because it helps me find the domain restrictions. All right, next up, 2x minus 3 and 3x minus 2, those look similar, but they are completely different factors. And so my LCD is going to have each of those factors. So we need the 3x minus 2 and the 2x minus 3. Kind of like the R and the S example. There's nothing in common there, and so our LCD was R and S. And so here, they're just binomials, but same concept. And then the other thing you want to watch out for is this is a minus sign. That always throws people off. Okay, so this first fraction is going to need a 2x minus 3 top and bottom. Remember, you have to do the same factor, top and bottom. And this second fraction needs the 3x minus 2. So now both fractions have the denominator 2x minus 3 and 3x minus 2. And so this first numerator is going to have a 2x being distributed to the 2x minus 3. I like to write it in front. And then this minus sign. And then we have a 3x that's going to be distributed to a 3x minus 2. Careful at this step. This is when people start trying to cancel things. You don't get to cancel these because of this minus sign. Anytime there's a minus or plus sign, you can't cancel. And so what we would do next is we actually have to simplify the numerator by distributing and then combining like terms. And so 2x times 2x would give me a 4x squared minus 6x. And then careful with this negative. This negative gets distributed as well. So that'd be negative 9x squared and then plus 6x. That's where all the mistakes happen. I'm going to highlight it for dramatic effect. This minus sign cancels with this minus, becomes plus. Okay, and then combining our like terms, we have a 4x squared minus 9x squared, which is negative 5x squared. And then negative 6x plus 6x cancels out to 0. And then we still need to bring our denominator back for for the final answer. Okay, and then always leave your denominators factored. That's going to help us find our domain restrictions later. Okay, now, here's where a lot of people make mistakes and say, okay, x minus 5 and x squared minus 25, so my LCD has to have this and this, and that's not true. And so, just like with multiplying and dividing, you want to factor everything that's factorable. And so this x squared minus 25 is a difference of squares, factors to x plus 5, x minus 5. And so these denominators already have a factor in common. And so once I have the x minus 5, that denominator is accounted for. We just need an x plus 5. And so my LCD here would be x plus 5, x minus 5. And this denominator would be divisible by this denominator and this denominator. So you don't want to go too big. You would end up with some degree 3 and degree 4, sometimes even degree 5 polynomials if you don't get the least common denominator. That's the key. And so we really just have to change this first fraction by giving him a factor of x plus 5. Okay, and so my common denominator that they both have is x plus 5, x minus 5. And then this first expression is going to have a 3 being distributed to the x plus 5. And then we still have this quadratic. The reason why I didn't factor the numerator here is because I would have just had to FOIL it all out later to clean up the numerator, just like we had to do a bunch of distribution here. And so you don't want factors in the numerator. And so distribute the 3. And then start combining some like terms. And so I have 3x and 21x, which would give me 24x. And then 15 and 30 would give me 45. And so before I bring back the denominator, we do want to try to factor it. And so you don't want to factor the numerators here. You want to simplify it first after you combine them. And then if you're left with a quadratic that's factorable, that's when you want to try to factor it, because it could cancel with one of these. So the first thing I'm noticing is 3 as a GCF, so I'm going to go ahead and factor that out. And then two numbers that multiply to 15 but add to 8 are 3 and 5. And so that's the numerator in its factored form. And then when I bring back the denominator, which was x plus 5, x minus 5, we do end up with a common factor. And so if you didn't factor this numerator, you wouldn't have seen that your fraction simplified even further. And so we're left with a 3 times the x plus 3, and you can leave that in its factored form, over the x minus 5. And you don't need the parentheses on bottom. It's not wrong to distribute the 3, it's just factored form is usually the best. All right, next, our denominators are x minus 3 and x. And so remember, you're only allowed to multiply. And so my least common denominator that's divisible by x and x minus 3 would need both factors. And so this first fraction needs x. This second fraction needs an x minus 3. I'm putting parentheses around the current numerators because we are going to have to distribute, and here we're going to have to FOIL. Okay, and so my LCD, my common denominator is x and x minus 3. And then I'm going to go ahead and distribute this x to get 7x squared minus 8x. And then we have our plus sign. And then to FOIL, we're going to get x squared minus 3x minus 2x, which is minus 5x. and then plus 6. Now, if that you would have to distribute the minus sign. And so you might want to get in the habit of putting this in parentheses so that you would know to distribute that minus sign. That's a common mistake I see. All right, and so since there's nothing to distribute, the parentheses aren't necessary, and so we're ready to combine our like terms. So I have 7x squared and x squared, which is 8x squared. Negative 8 and negative 5 is negative 13. And then we have a plus 6 at the end. Now, I'm not sure if that's factorable or not. It could be. But I know x minus 3 is probably not going to be one of the factors. And so because I think something's not going to cancel, I'm not going to go ahead and factor it. All right, looking at number 6. This is a little bit different because these aren't quadratics or trinomials. There's no plus signs or minus signs. So as you build your LCD, you already have factors. You have 3, you have an x, and a y squared. So I know minimally I need a 3, I need an x, and I need a y squared. And then looking over here, we've almost accounted for all of his factors except he has an x squared. So I need an extra x for my LCD. So now when you look at this LCD, 3x squared y squared would be divisible by this and divisible by this. And it's this least common denominator between those two. Okay, and so my first fraction almost has this denominator. He just needs an extra copy of x, top and bottom. And then my second fraction, he is going to need I don't want parentheses there. He's going to need a 3, and he's going to need an extra copy of y. Okay, and so my LCD is at 3x squared y squared, and they both have that denominator now. And so to clean up the numerators, distribute your x, and you get 7x squared plus 2xy. And then careful with this minus sign. We're distributing the 3y. And so if you want to think of it as distributing a negative 3y, that would leave us with a minus 6xy. And then a plus 15y squared. And then we need to combine these like terms. So we have 7x squared minus 4xy plus 15y squared over 3x squared y squared. And you don't have to try to factor that. Okay, that's similar to something we've done. Let's do number 8. And so first things first, factor everything that's factorable. And so x squared plus 5x plus 6 factors to x plus 2, x plus 3. And so my LCD is going to need the x plus 3. They both have that in common already. And then we also need an x plus 2 to account for this factor. So everybody's factors have to be accounted for. So my first fraction doesn't need anything. He's already got that LCD. But my second fraction needs the x plus 2. Okay, and so I like to write one big fraction bar with that LCD. And it doesn't matter which order you write the factors in. And so now we have this 7x plus 4 minus this 2 times x plus 2. So I'm just going to write it down right now so I don't lose that minus sign. And And so now we're distributing a -2. I can't emphasize that enough. That's the most common mistake. And so 7x plus 4 minus 2x minus 4, which leaves me with 5x, and the 4's cancel. And we still have x plus 3, x plus 2. Right? And so let's look at these last two and we're done. And so to get an LCD between 3 denominators, we have to count for everybody's factors. So we have an x plus 2 factor, we have a 5 and an x, and then we have an x. And so we need that x plus 1. We need the x, I'm going to put that in front, and we need the 5. Okay, and so looking at this LCD, this first denominator divides it, the second denominator divides it, and the third one divides it. And so our first fraction just needs the 5x. My second fraction needs the x plus 1. And my third fraction needs the 5 and the x plus 1. Okay, and so my LCD is 5x, x plus 1. And then my first numerator becomes 20x squared. And then I have this minus sign. And then I have this 3 times the x plus 1. And then I have this second minus sign. And then 5 times 4 is 20 times the x plus 1. So now we just need to clean all this up, distributing a -3. I would get a -3x minus 3. Distributing a -20, I would get -20x minus 20. And so 20x squared, -3 and -20 is -23x. -3 and -20 is -23. I believe that is not factorable. So bring back your denominator, and you are done. Oops. All right, last one. This factors to x minus 4, x plus 1. And so my LCD would have the x minus 4 and x plus 1. So we just need an x plus 1, x plus 1. So x minus 4, x plus 1. And then writing our numerator, have a plus sign. Then we have a 2x times an x plus 1, which we can go ahead and distribute. 2x squared plus 2x. Careful distributing that 2x to the 1. Right? And then this -x squared and 2x squared becomes, I don't want to cross those off. It looks like things are canceling. -x squared plus 2x squared is just x squared. And then we have a plus 2x and a minus 24. Just simplifying the numerator. And that easily factors to x plus 6, x minus 4. And so then when I bring back the denominator, I can see there is a common factor that cancels, and you would miss it if you didn't factor the numerator. And so my final answer would just be x plus 6, x plus 1. Remember, those x's don't cancel because we have those plus signs.